streaming. And get rid of this. I've been working on some stuff with the Design Hub that makes use of that. So that's gone, gone, gone. Okay, get rid of that. All right, so we got two main things that I need to go through today. The first one is to go over the relation quiz. I have heard everything from super frustration to super fascination, as the result of doing this homework assignment. So, and everything in between, I'm pretty sure. Okay. So we'll go over, the quiz, and we'll also go over a previous exam from spring semester as the practice exam for our first exam, exam 1. So exam 1 is supposed to be in week 6. Next week is week 6. So my usual way of doing things is I will do a practice test 1 week prior to the actual exam. So that way when you guys study, you have one class, okay, one class meeting to ask any questions about things that you have reviewed but you have no idea, or you have some confusion, or you need some clarification. So we got one extra class to work on those things. Okay. The scope of the exam is everything up to what we have talked about up to this point. So that means resolution, not resolution. I take resolution out because we haven't done the resolution assignment. But by the time we take the exam, we would also have done CNF. So CNF, propositional logic, is going to be in the scope, but resolution, proof by contradiction, is not. All right? So I'm only going to quiz you guys on, based on the scope of things that we have already done homework assignments on. Yes? On Wednesday. So it's 1 week from today. So let me first get to the class, and then I'll send you an announcement. So this way it is more official. So I'm going to add an announcement here that says exam 1 is on. I believe that's October 3rd. Is that correct? 1 week from today? It sounds about right. Yep. Okay. So no need for any text in the body. So just click save. Oh, it doesn't let me do it. Do you think it will take some empty spaces? Let's find out. Yep. That's not very smart. A very simple regular expression would have caught that. All right. So that's done. So the next thing we need to do is to go over the relations assignment. So I do have to point out, some people pointed out that the concepts were not well understood, and that's why this homework assignment was kind of difficult. Well, okay. So it's important to bring those questions to me as soon as possible. If there's something that people do not understand, do not wait until the assignment is due. Kind of ask those questions as soon as possible, because we have been off of the relations topic for at least 2 class meetings already, because we have been talking about propositional logic for some time already. So that means, well, don't wait, you got to get these things cleared away as soon as possible. So that's just me nagging, basically saying, if you have questions or something is not clear, it is most helpful in the same class. Okay, when I talk about a particular concept, if it's not clear, ask questions. Okay, during the class when I'm on that topic. Okay, if someone says, but I don't even know what to ask. Okay, what do you think? What do you guys? What are some of the suggestions? Well, if I repeat the topic, I will explain it kind of the same way. So the first thing is to identify which part a person is not understanding, because unless it is everything, okay, in which case we have a serious problem. But if it is just one thing, it's like, okay, I understand all the properties of relations except for this one. So that's kind of narrowing the scope quite a bit. Okay, which part of that is not clear? Well, according to this definition, I'm not really understanding the definition. So if I give you this example as a relation, is it this or is it not this? Okay, that is a much better question because now it's narrowed down to a single concrete example of whether it is or it is not, one of those properties. And I can talk about that. Okay, that's something I can go over and go like, wow, that's a good example. Let's talk about this one. Okay, so just for future references, I cannot turn back time. Okay, and I think I might have told you guys already that I cannot read minds either. So if you have a question, I cannot tell. Okay, sometimes I can tell from the facial expression, and that's why I paused in class and asked, do you guys have any questions? Really? Do you guys have any questions? That means, I can tell from some facial expression that there are questions, but you need to bring those questions up in order for me to answer them. I cannot telepathically read the question and telepathically answer that question. Is that okay? All right? All right, so we're going to go over the answer, and as we go over the answer, if there's anything that is not clear, okay, I don't understand why it is blah, 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 or why it is not blah, 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 we'll go slow and have those questions answered. So I'm going to go do a preview. Question number 1. Is the font size okay for people in the back, especially the far corners? Okay. So question number 1 is asking, consider the not equal to relation defined over all integers. In other words, this is the same not equal to relation that you have been using in C and C++, all along. Which of the following relation properties apply? In other words, I'm asking, is it transitive? Is it totally ordering? Is it partially ordering? Is it reflexive? Is it anti-symmetric? And is it symmetric? So the first thing we need to do is to find the definitions of these things. Okay? So unless somebody asks, I'm not going to bring up the definitions unless you guys say, okay, but I want to look at the definition. Transitive means for every way to pick out 3 things, 3 integers. They can be the same integers. They can be 2 integers, so you can repeat 1 integer twice, or they can be all 3 different integers. Okay? So for every single way of picking 3 integers, let's call those A, B, and C. Okay? Is it true or not that A does not equal to B and B does not equal to C implies A does not equal to C? That would be transitive. Yep. 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 So let me repeat your example. If you pick A equals 1, B equals 2, C equals 1 again, then A does not equal to B, okay? B does not equal to C, and yet it is not true that A does not equal to C. So as soon as you find one counterexample, when you're dealing with a for all, that property does not hold true anymore. Okay? So we know it is not transitive. Is it totally ordering? Well, that depends on whether it is even partial ordering. Okay, so let's answer the question of whether it is partially ordering or not. But partial ordering also relies on whether it's reflexive, anti-symmetric, and transitive. But guess what? We know it's not transitive already. So that's why it cannot be partially ordering, cannot be totally ordering either. Is that okay? So we have just we have just answered the first 3 of the whole bunch. Is it reflexive? Reflexive means a relation, every element relate to itself using that relation. So the question is, if I pick any integer out of the set of all integers, does that integer not equal to itself? No. Every integer equals to itself, so it is not the case that it does not equal to itself, so it cannot be reflexive. Is it anti-symmetric? Anti-symmetric means given any way of picking 2 elements out of a set, they can be the same. If A does not equal to B and B does not equal to A, does that imply A equals to B? Okay, let me say that one more time. For any way to pick out two integers, not necessarily distinct, okay? A does not equal to B, and B does not equal to A. Does that imply A equals to B? I mean, that is pretty clear. No, okay? So it is not anti-symmetric. Last one, is it symmetric? The definition of symmetric is if I randomly, for every single way to pick out two things out of the set of all integers, okay, does A does not equal to B if and only if B does not equal to A? Yep. Check. And there's only one check in this case. It is only symmetric, but none of the other. So are there any questions about this? Now, put yourself in my shoes, okay? Not literally, because I got pretty small, flat, but wide feet, okay? So it's pretty hard for anyone to be in my shoes, literally. Anyway, put yourself in my shoes in terms of assigning points to these answers. This is a multiple choice type of question. In other words, more than one can be selected at the same time, okay? So how would you, if you were me, assign points to this question so that, people who say, I'm going to shotgun this, I'm going to check every single box because I'm bound to hit everything that I'm supposed to check anyway. Yep.
A relation to how many you got right to how many you selected?
Well, my equation is simple. If you add up the scores of all the wrong answers, they equal the score of the right answers. So the sum of the scores of the wrong answers would equal to the score of the sum of all the correct answers. And they're evenly distributed. So in this case, because there's only one correct answer, it's worth 1 point. So for each wrong answer, it is worth, how many wrong answers are there? 5. So each one is worth a negative 0.2 points. So anyone who's checking every single box here will get a 0, which I think is fair. Now, if someone, for whatever reason, checks all the boxes that are wrong and missing the box that is right, potentially that's a negative 1 point.
So you're going to have to create a label, you're saying? So is Canvas already keeping track of that?
Yeah. Canvas is doing that already. So I am already using negative values for the incorrect answers. Okay, so question number 2. Consider the equal to relation over integers. So these are all, relations that you know from programming. Okay, it doesn't even matter what programming language it is. Over all integers, which of the following relation properties apply? Basically the same thing. You have to go through all of these and pick out the ones that apply. So this is equal to partially ordering. We don't know yet, because and totally ordering also depends on partially ordering. So I'm gonna kind of wait a little bit before I answer those two. So we'll deal with reflexive. If you pick any integers from the set of all integers, does that integer equal to itself? Does it relate to itself? All right, so check reflexive. Is it transitive? Now, it sounds kind of odd, right? Okay, it's equality transitive. But think about it. The definition of transitive is for every way to pick 3 integers, remember they can be duplicates, okay? A, B, and C. If A equals B and B equals C, does that imply A equals C? Yes. Well, that makes it transitive. Is it anti-symmetric? In other words, if you pick out any 2 integers from the set of all integers, okay, and you say, if A equals to B and B equals to A, does that imply A equals to B? If you spell it out like that, it kind of answers the question itself, right? So yes, it is anti-symmetric. And the last one is it symmetric? In other words, A equals B if and only if B equals A. Does that apply to every single way you can pick A and B from the set of integers? Yes. So it is also symmetric. So because it is reflexive, it is transitive, and also anti-symmetric, it is also partially ordered by definition. Now, if it's partially ordered, it has a chance of being totally ordered, but being totally ordered means if you pick any two integers out of the set of all integers, they have to relate using the equality. But that is not true for equality. If I pick 2 and 6, okay, out of the set of all integers, okay, 2 does not equal to 6, 6 does not equal to 2, oops, it's not totally ordered. Is that okay? All right. Question number 3. Now, question number 3 gets to become a little bit more abstract because I'm not even telling you what X is, what the set that the relations are defined over. I'm not telling you what R is. I'm not telling you what S is. I'm not even telling you the cardinality of X. Okay? Just pick any X. Okay? So regardless of how we choose R and S and X, okay, we know one thing for sure. We know the intersection of R and S is reflexive. So now you have to remember what is intersection. But that is not fair, Tech. This quiz is about relations. How come we have set operators in it? Well, because we're defining relations as a set. So very naturally, we can expect to have set operators when we talk about relations because each one is a set. So the intersection is known to be reflexive, which means every element in X relate to itself. Okay? Doesn't matter whether you're talking about the R relation or the S relation, because that's the common part. The intersection is the common part between two sets. So that means we know for sure that R is going to be reflexive. The other ones we cannot confirm. They may or may not be the case, but we don't know. In other words, you can construct cases where R is symmetric, but you can just as easily construct cases or examples where R is not symmetric. And the same thing with anti-symmetric and transitive. But we cannot use none of the other answers can be confirmed because it is reflexive. Are there any questions about this one? The partially ordered one? Yeah. You mean 1 or 2? Question number 1. Number 2? Okay, so totally ordered means it has to be first to be partially ordered. Everything that is totally ordered is automatically partially ordered, but not the other way around. Okay, so that's the first thing. But in order for a relation to be totally ordered, in addition to all the properties of being partially ordered, you also have to satisfy the following requirement. I'm just going to say out here. For every way to pick out two elements over the set, A, RB, and BRA implies ARB or BRA. So it has to be one or the other. Every two elements have to be related, but it can be in either direction. Oh, no, because it applies to every way to pick out two elements. Okay, so I'm gonna write it out on the tablet because this way we can have it recorded. The thing about having everything recorded is if I make a mistake, it's also recorded. I like that actually. If I make a mistake, well, I don't have a problem of having my mistake recorded. Because if I make a mistake, I make a mistake, right? I mean, it's as simple as that. All right, so we are basically saying for A, B, for all ways to pick out A, B in whatever set that you are defining the relation over, A, R, B, or B, R, A. If this requirement is satisfied, then then this is the last quality or the last property to become totally ordered. Is that okay? So now we are talking about integers and equal to, right? All right, so we'll say, what about A equals 1, B equals 2? Then A equals B is false. B equals A is also false. False or false is false, so the entire thing inside here is false. So that means I can no longer say it is for all, which also means once we try to apply the universal quantifier, the whole thing is false because I can find a counter example to that. Is that okay? All right. Any other questions? No other questions? Okay, so we're gonna move on. Question number 3 is done. Let's look at question number 4. Consider the less than relation over integers. Which of the following is going to apply? Okay. Is it reflexive? In other words, is every integer less than itself? Nope. Okay. Is it symmetric? If A is less than B, does that imply B is less than A? Nope. Is it anti-symmetric? If A is less than B and B is less than A, then A equals to B. Now you have to think about this one carefully. It is actually true. Less than is anti-symmetric. Okay, because of the implication. Okay, so let me switch back to the here. Okay. So in order for something to be anti-symmetric, it says for every way to pick 2 elements out of X, okay, it wants A R B and B R A to imply A equals B. Okay. And now the R is less than, okay? So now we are really asking for every single way to pick 2 elements out of all integers, because X is the set of all integers. A is less than B and B is less than A implies A equals to B. Is that implication holding true for every single way for me to pick A, B out of the set? Yes. Okay. So let me do this for all A, B in the set of all integers, which is Z. Okay. A is less than B and B is less than A implies A equals B. Okay. This looks awfully dubious, right? I mean, you guys probably recognize that cannot be true. And you are absolutely right about something cannot be true, okay? But that something that you know intuitively cannot be true ends up making the entire thing true. Let me point out what it is. This part here is guaranteed false, right? An integer cannot both be less than and also greater than another integer. Okay, so this is always false. So I'm really asking, is false implying A equals to B for any way you can arrange A and B? The answer is yes, by the very definition of implication. Tell me what is implication again? A implies B is not A or B. Okay, so if A is false, what is not A? True. What is true or whatever? True. There you go. It's better to have this caught now than in the first exam. So think positive. Yep.
Two quick example questions.
Yep. less than or equal to is also anti-symmetric. Yep.
Can you give an example of when that's not anti-symmetric?
Okay, so for something that is not anti-symmetric, you have to find a particular case where this statement is false for at least one way of picking out A and B.
I couldn't think of one.
So 1 and 2, for example.
Not equal to? Not equal to is not anti-symmetric. We worked on that one a little bit earlier. Because if A does not equal to B and B does not equal to A, that can happen at the same time. But if A does not equal to B and B does not equal to A, which is kind of like repetitive, does that imply A equals B? No. So we find at least one example where this cannot hold true, so it's not true. So are we good so far? Any other questions before we move on to the next question? Nope. Okay. So let's go ahead and move on. Anti-symmetric is true. Is it transitive? We are talking about less than now. If A is less than B and B is less than C, does that imply A is less than C? Yep, makes sense. Is it partially ordering? Well, it's not, because it's not reflexive. If it's not partially ordered, it cannot be totally ordered. So that's basically the answer of this one. Question number 5. Greater than or equal to? Don't you just like all these questions? Is it reflexive? Is every number greater than or equal to itself? Yes. Okay, because of the equal to, it is actually reflexive. Is it symmetric? A is greater than or equal to B if and only if B is greater than or equal to A. Nope. Okay, it's not symmetric. Is it anti-symmetric? A greater than or equal to B and B is greater than or equal to A implies A and B are the same. Yep. Is it transitive? Yes. So is it partially ordered? It is partially ordered because the 3 requirements to be partially ordered are all met here. Is it totally ordered? In other words, if I pick out any 2 integers, can I say, well, A is greater than or equal to B or B is greater than or equal to A? Yep. So that means it is totally ordered. It is not symmetric. Symmetric says for every way to pick out A and B, okay, A is greater than or equal to B if and only if B is greater than or equal to A. Is that statement true? Well, the statement is not true because if I pick A to be 1, B to be 2, then B is greater than or equal to A is true, right? But A is greater than or equal to B is false. So true implies false is false. I find one single counter example. So now the quantifier, the universal quantifier is negated because if you find one example where the statement is false, then you cannot say for all anymore. Is that okay? Okay. Question number 6. If R is a relation defined over X is known to be reflexive, which of the following do we know for sure regardless of the actual definitions of R and X? Okay. Well, what do we know for sure? If you know the number of elements in the set, you need at least that number of elements in R. Don't you think? Because every element has to relate to itself. So that means it has to have at least as many elements in R as there are in X. Okay. So now we have a few suspicions. We can rule out R does not equal to X, okay? Or the cardinality of R does not equal to the cardinality of X because that's negating what we are just saying. But we have some choices. This one can be thrown out too. The cardinality of R is less than the cardinality of X. We can throw that one out too. But now we are left with greater than or equal to, and potentially none of the other, okay? So how do we work this out? Is it exactly the same, or is it at least, or is it, we don't even know that. It's greater than or equal to. Because you can throw in extra stuff, it doesn't make it not reflexive. Once a relation is reflexive, you can add more stuff to it and it is still reflexive. Okay? So the answer is the first choice. It is not strictly equal to, it is just greater than or equal to. Question number 7. If R is a relation defined over X and R is known to be symmetric, okay? But I don't tell you any details of why or how it is symmetric. Which of the following do we know for sure, regardless of how R and X are defined? Okay. So we go through all of the potential answers and say, okay, can we confirm that? Can we confirm the number of elements of R equals to the number of elements of X? Nope, because an empty relation is automatically symmetric. So you can make your X as big as you want and R to be an empty set, it is symmetric. So that throws out equality. Can we guarantee that R does not equal to X? We cannot guarantee that, okay? They can be the same. Can we guarantee R is greater than or equal to X? So the question is really asking, can you come up with a counter example such that the number of elements in R is less than the number of elements in X? Well, we just came up with one, right? The empty relation. But can we guarantee the number of elements of R is less than the number of elements of X? No, because anything that is just barely reflexive is also symmetric. But in that case, the cardinality are the same. Can we guarantee the cardinality of R is even? We cannot even do that. Think of X having a single element, okay? And R is the element relating to itself. So now we have a cardinality that is odd, but R is also symmetric. It meets all the requirements of being symmetric. Is R guaranteed to be odd? No, because you can come up with an example where R is even, or the cardinality of R is even, but yet it is also at the same time symmetric. What about this one? The cardinality of R is exactly twice of the cardinality of X, because you can also come up with an example where that is not true. Okay? So if all of these cannot be true, then you are forced to only answer none of the other answers is correct. As Sherlock Holmes would have said, once you have eliminated all the possibilities, whatever possibility is left, no matter how unlikely, it's got to be the only case, right? Not those exact words, and I cannot remember exact phrases. So is that okay? So the quiz is really designed to not to trick you, but to really test whether you understand the concepts or not. Okay, that's the goal of the homework assignment. It's not really worth that many points in terms of when you add up the total, because every single homework, all the homework assignments added up, is only about 20%. It's only exactly 20% of your final grade. Your first exam is 20% of your final grade. So that really kind of gives you a scale of, oh man, I totally blew this one. Well, okay, it's not that big of a deal. It's better to blow it up now than not understanding that some of the concepts have been misunderstood and then carry that to the exam. That would really hurt. This hurts a little bit, but you can rectify. Is that okay? All right. So of course, I have to confirm that I have all the keys done correctly, right? Because I have been known to enter wrong keys into my own quizzes, Yep, so this time I got a 7 out of 7. Okay. So are we okay so far? Are there any questions about relations? Because now is a good time to ask, when right after we talk about all of these questions and concepts. Okay? So if there are no questions, I'm going to bring you to the practice test. Okay? So the practice test, I'm just going to access the practice test separately here. It's the actual exam one from last semester. So cisp440. Oh, not shared. It's not shared yet. So let's go back to the previous semester. And this is exam 1 from the previous semester. Did you guys notice that I have an avatar now? No? Man, you guys don't notice the little things. And I changed my glasses? Maybe it's a good sign you guys are just focusing on the class material. Yeah. Okay, so I'm gonna magnify a little bit. Okay. Obviously, this is from last semester, so the time and room number, date, can be wrong. This is CMC 407, I think, so, and last semester I had it in the next room. The time is going to be the same as the lecture time, so just next Wednesday, instead of having a lecture, we'll have the first exam. It is still going to be open book and open notes, but no electronics other than a scientific calculator. I don't really think a scientific calculator would help, but if you think it's going to help, or you just want to make sure that you have it when you need it, bring a scientific calculator. Not a problem. The assessment is individual, so I have to kind of explain this part. The score should only reflect the competency or academic performance of the student with the name and student ID, that person put into the test, as indicated above, which means that's the earlier part of the exam sheet, without any prior knowledge of the exam questions. So I have to add that part because just in case someone had some mean or whatever means to get the exam questions prior to the actual exam. And I don't really care how it is done, okay? It can be someone who's taking the exam a little bit later than the rest because that person was sick, or someone telepathically read my mind as I'm trying to come up with these questions. So the means is irrelevant. It's the deed that counts, okay, or the result that counts. Answers should be independently and originally derived in the allotted time frame, observing all the rules applicable. Okay, so that means when it's time to turn it in, it is time to turn it in. Okay, if someone decides, I got one last question, one last part to finish, even though the time is up, according to this, I don't have to take that exam. Then that person actually has all eternity to finish the exam. But it's not going to help. No sharing of open notes or open book material during the exam. Oops, I forgot to bring my own, material, and I see the guy next to me is like, oh, okay, that person has got everything. Can I borrow that? No. Okay? Do not discuss the questions with students who may not have taken the exam. If you do not know whether the other person has taken the exam, don't tell that person anything about the exam after the exam. Okay? Any questions about the individual assessment part? Okay. Use additional sheets of paper if necessary. So this is a big clue, big hint to those of you who think, okay, I might actually cross out a whole section of answers and I need some additional pieces of paper to write the actual correct answer. So bring paper with you, Okay, you can use binder paper, you can use plain paper, you can use graph paper, as long as it is not too wrinkled up, it's okay. Because I put everything through my scanner. If it's too wrinkled up, it's gonna jam my scanner, and I'll be pretty upset about it. And then I'll remember who did it. Okay, so write legibly. Okay, that part is cool. Write legibly because I cannot give any points to answers that I cannot interpret without post-exam examination. So that means if someone gives me an answer that looks like this, and then after the exam they say, this really means not reflexive and anti-symmetric. I'm sorry, I cannot really take that as the answer. In explanations, start with definitions that are discussed in class or written in notes, then use logic to explain, step by step, how the conclusion is reached. So that is required because this is how I can assess whether you can apply what you have learned, not just whether you know the answer or not. And this exam accounts for 20% of your final grade. So are there any questions about the first part here? Basically just the rules and how it's set up, what you can do, what you cannot do, blah, blah, blah. There's no limitation of how many pages or how many books you can bring with you. Okay, I know some classes have a limitation like that, like one sheet of paper, and they limit the size of the paper. Okay, there's no such limit here. Okay, if you want to print out all my modules, okay, and have stickies and annotations all over that, and another 2 textbooks that other people use for discrete structure, bring it. Okay, if you think it's going to help, bring it. Okay, because I don't want anyone to tell me I cannot remember blah 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 blah. Okay, so if you find something that might be helpful, okay, that will give you what you need to know during the exam, bring that resource with you. Now, different people have different material that they will think is useful. Some people may not bring my notes at all because they have been taking notes in class, so they will just bring their own notes with them. Okay, some people may go, oh, I really like that screen during one of the lectures from the YouTube recording. Well, guess what? Take a screenshot, print it out, bring it with you. No problem. Oh, I really like that screenshot of your class 2 years ago. Take a screenshot, bring that with you. So time limit is not a limitation. The only problem is taking a screenshot in the future when I talk about the key to this exam. So that would only apply to Time Lords. So if you're the doctor or the master or the mistress, you might have a problem. But if you're not a Time Lord and you're not capable of time traveling, you should be safe. If you're a Time Lord, I don't really see the point of taking this class. All right, so the first question is, once again, relations. And it says if R is a subset, not proper subset, but just a subset of X, Cartesian product with X is a relation defined over X, we know that R is partially ordering elements of X. Okay, so it's given to you that it is a partially ordered relation. In all cases, how does the cardinality of R relate to the cardinality of X? Explain your answers step by step, starting with the definition of partially ordered. Okay, yep. Say that one more time. So if you just say greater than or equal to, you will get major deduction from the point values because it's not step by step, and you're not starting with the definition of what is partially ordered. So don't jump to that conclusion. Even if it's right, you still have to go step by step and explain it. Okay, so let me try to answer that question here. Okay, so I'm going to switch to my tablet here. So we are asking about partially ordered. Okay. So the first thing you need to know is what is partially ordered. We know it includes being, whoops, reflexive. It has to be anti-symmetric, and we also know there has to be transitive. Okay. So those three are requirements for something, for a relation to be partially ordered. Reflexive alone, okay, which is something that we just talked about, guarantees that R is greater than or equal to the X in terms of cardinality. So we have at least the greater than or equal to. Okay, so this guarantees it is greater than or equal to. But let's check the other one and see if they would imply anything about the cardinality. Anti-symmetric is saying A RB and BRA implies A equals to B. But if something is just reflexive, does that imply it is anti-symmetric? It does. So that means it doesn't really add any extra properties as far as the relationship, the size comparison of the two sets. What about transitive? If a particular relation is just reflexive with nothing else, is it also automatically transitive? It is. So that means we also cannot use transitive to add any more to imply the relationship between the cardinality. So that means the only thing we can really guarantee is greater than or equal to, and that's it. So I did a lot of verbaling without writing it down, but in your answer, you have to write that down. Okay? But the correct answer is yes, it is just greater than or equal to, but in your actual answer, you will have to write down the components of being partially ordered, and on top of that, explain, how each one has implications to the comparison of the cardinality. This has no impact. This has no impact. This one does guarantee it's greater than or equal to because every element has to relate to itself. Okay? And it doesn't have to be in mathematical symbol. It can be just sentences in a language that I understand. Sometimes I think of all the different ways that I could have argued with my own professor, so that's why I have to explain things like that. I can make a very bad student. Question number 2. Given that X is a set of ABC, how many ways can one define a function f that maps X to X? In other words, X is both the domain and the codomain. Note that the function does not need to be injective or surjective. Okay? It doesn't say that it cannot be. It simply says it's irrelevant whether it is injective or surjective. Explain your answer step by step. So there are several ways to do it. One way is to exhaustively list every single way. Okay, that's one way, but it's going to be quite tedious. The other way is to just explain, okay, verbally, how you come to your conclusion. So how would you approach a problem like that? What is going through your mind? What makes a Cartesian product a function? Go ahead.
State that the domain everything in the domain must be so there's 3 arguments.
So the number of elements in the domain is a component of whatever number you're working with, okay? But the next question is, and then what, okay? So you have to think about, okay, we know that every element in the domain has to map to one element in the codomain. Which one? We don't care, okay? A function simply says each element of the domain has to map to one element in the codomain. Can be any one of the 3. Yep.
Wait, so like at first I was thinking like each element in X
Mm-hmm.
are like 3 times, but then if you have any duplicates,
It can be duplicates. In other words, it's perfectly okay for A, B, and C all to map to just A. It is not injective anymore. It is not surjective anymore. but I specifically say that that is not an issue. So that means A has three possibilities. A can map to A can map to B, A can map to C. Pick one, right? What about B? Well, same thing. B can map to A, can map to B, can map to C. Does that depend on whether A has already mapped to that element? No, because that is only a concern when I care about injectiveness or surjectiveness in some cases. Since I specifically say that I do not care, that means well, they can all map to the same thing for all we care. What about C? Same thing. It can map to A, B, or C. Wait, when A maps to A, it doesn't have any limitation of what B can map to. And when B maps to A again, it has no implication of what C can map to. So they're completely independent. So that means the answer is 3 times 3 times 3, or 3 to the power of 3. Is that okay? So your explanation has to kind of capture what I said, okay, in words. Is that okay? But the best way to start with this question is really go back to the portion before the first question, is to start with the definition of a function. The restriction of a function is every element in the domain has to map to one element in the codomain. Without further restrictions of injectiveness or surjectiveness, then we have no restrictions of whether they can map to the same thing or not. So that means it's completely independent now. Okay? So that's question number 2. And then question number 3 has a little bit of coding here. So given that xy is an element of n, and in this case, its n is, I can't use the funny looking n because of Google Documents. So, this n really means, natural numbers, and that's why I have to explain, x and y are natural numbers. And we also know x is greater than 0 and y is greater than or equal to 0. So 1 is 0, 1 is greater than, 1 is greater than or equal to. Assume g is the 2D to 1D mapping function in the Aleph null module, okay? So that means you probably want to have that module available or remember what the function g does, okay? We know that g of xy is greater than y. This allows us to encode a null terminated string to a single natural number and reverse it back to a string. An algorithm to do this may look like this in pseudo C, okay? It's not strictly C, but it's close enough, okay? And then it goes to this part here. This means that the encoded unsigned value of TAK tag is, if you expand out everything, it is TAK and then the null terminator. Okay, and that's what the algorithm is going to do. In the following space, write a function called length in pseudo C. Okay, so you can be kind of not entirely syntactically correct to find the length of a string that is encoded by the function called encode in the question itself. You may use the notation g superscript -1 for the inverse function to mean the inverse function of g, and use this way to extract both values out of the inverse function. Because g maps two natural numbers to a single natural number, so that means the inverse of g is going to map a single natural number to two natural numbers. Is that making any sense? Okay? To get the values of the inverse function applied to a natural number, for example, length k should return 3. K being this k over here should return 3. There's no need to define g or g inverse because we have those defined in the notes already, so we can just use g as they are defined in the notes. So there's no need for you to repeat the definition here. I'm including the opening of the function. So the opening of the function is telling you that you have a single argument of n, which is the single integer natural number, not integer, but natural number that the string is encoded into. And your job is to find out the length of the string that is encoded as n. Okay, so how are you going to do that? First of all, first thing is to read that function and understand what the function is going to do, because what you're doing is undoing it. Okay, so by understanding how it's done, you can undo it. All right, so we'll go to this function here, and we go like, this is one of my favorite questions in this test. So the function has two arguments. One is the string itself, and the other one is I, because it is recursive. Okay, so I is an index. It starts off with 0, and then in the function, this is a recursive subroutine. And in cisp440, have you guys talked about recursion? Not yet? Okay, now you get to see it first. Now, is recursive subroutine something that is, okay, the first sentence that came to mind was not politically correct, so I have to think a little bit more. If you understand subroutines, okay, and you're not asked to write a recursive subroutine, you're only presented a recursive subroutine and understand what it does, do you think it is a reasonable expectation once you have taken CISP 360 and 400? So I would assume so, okay? But if someone is disagreeing, that person can contact me after class, or file a grievance with the dean, okay? Then I can explain, the whole concept of recursion to the dean, which I might actually enjoy. Because my dean is an English major. That makes it even more fun. Because I will start with, so, Kirsten, do you know what is GNU? GNU. No, GNU, you mean the animal, right? No. GNU, by definition, GNU is not Linux, is not Unix. G and U, right? GNU is not Unix. So, but that doesn't really explain what GNU is. No, it does fully explain what GNU is. GNU is not Unix. It simply is not Unix. Yeah, I wonder how Kirsten is going to react to that. My performance review is next semester, so I'm relatively safe this semester. Okay, so.
Are you tenured?
Yeah, have been tenured for some years. All right, so getting back to this subroutine, encode, okay? So str is really a string, okay? It's a pointer to characters, okay? And I is just an index. So the first thing I do is I'm checking, okay, is index I of string different from 0? Well, what if it is? Well, if it is, I'm done, because I have just I'm looking at the end of the string. I'm done, okay? And what do I do when I'm done? I return 0. So 0 is encoded as 0 itself, okay? There's no actual encoding here. What if it is not? Well, then I'm going to do some recursion. Result, which is a local variable that is returned later, is going to be the G of, okay, the character that I'm responsible for, and the encoded version of the rest of the string. So you can see how the recursion is using the same string, except it is using the index is the next available character. Okay? So this is how I encode it. And from this, you can expand the string tak and then the hidden null character to be t first, because t is going to be the first character in the first. The second component to the first call to G is going to be the G of the rest of the string, which is AK, right? So we have A and then the K, but K being the last character. When K is stri and I call encode again, the last invocation of encode is going to see the null terminator. The null terminator always returns a 0, and that's why it is going to be a 0 here. Is that okay? So this is basically another way of helping you to understand what the subroutine is doing. So the question now is, I'm looking at the constant k here, okay, the value k. How do I know the length of the string that is actually encoded into k? That is the question. Is that okay? So how do you unravel it? Hmm? Exactly. Yep. So you first check whether n itself is 0. If n is 0, that means you're looking at the encoded null string. That's the 0 here. What if n is non-zero? Okay, so let me scroll down here. So what if n is non-zero? Well, if n is non-zero, then you have to apply G inverse to find out what two things n is encoded, and what is encoding into n. The first thing of the G inverse is the actual character. The second thing can potentially be a substring, whatever is to the right hand side. So then you recursively call that and go like, is there a string here? Okay. So to actually write the code, I'm going to write the code here, and I will share this document with the entire class. In fact, I'll do it right now. So file, move to, let's see, I'm moving it to the parent folder and then to shared. Okay, right there. And I don't remember whether I have subfolders for exam 1, 2, and 3, but if there's none, I can always name it in a certain way. Yep, it doesn't, so I'll just move it here and then change the name to 1183-x1. 1183 is the internal semester code used by ARC, to name semesters. Okay, so now you guys have access to it. All right, so as any type of recursive subroutine, you always have to check for termination. Okay, and this is the actual way that I write programs. I just spell out the skeleton first. Okay, and I always I try to avoid using return inside the conditional statement. So I'm going to say unsigned result here, and if I get to the else case, what is that telling me? N is 0. If n is 0, what is the length of the string encoded into n? 0, because it's just the null terminator itself. Okay, so in this case, I can say result is 0. And don't forget the last return result here. All right, so what if n is non-zero? Then I have to break it up into the two components, right? The x and the y. So now I have my local variables x, y, so that I can use what is suggested in the question itself to capture G inversed of n. Okay. So this is supposed to be a superscript, and I think I can change it to superscript. Yep. There we go. So once we have the x and the y, the x is guaranteed to be non-zero. Okay, which means we have at least one character in the string encoded into n. But what about the rest? I don't know, and it's not my job, because I'm going to call the subroutine recursively to find the length of the rest of the string. Is that okay? That is the best part of recursive subroutines, is you're only responsible for one small part of the entire puzzle. As long as you can present the rest of the puzzle in the same form of the puzzle that you are solving, you can then just call recursively. So now I can say result, okay, is 1 plus. Okay, the 1 is accounting for the non-null character x, and then I just call length again, but this time it's processing y, which is the encoded natural number of the rest of the string. So something like that, is going to work.
But you had to write it like in pseudocode, or you had to write it in actual C++?
It says right here that you have to write it in a pseudo C code. So as long as the logic is clear and it vaguely resembles C, it's fine.
Could you explain one more time that line x comma y equals to g and negative 1? No. Yeah. Oh, okay.
Yep. So it's coming from the question itself.
Yep.
It is a way to capture a two tuple as an answer of applying a function. Yep.
So in this case, x is the character,
Mm-hmm.
and y is g of n minus 1.
Y is okay. Whenever you apply G inverse to a natural number, it always returns a two tuple. The first element of the two tuple is the character, the first character of the string. The Y is the encoded version of the rest of the string, and that has to do with how things are encoded, and that's why K is defined like this. When you pass TAK and a null character, you can see how the ordering of TAK and the null character is specified here.
So in the x part, it would be 0, and the y part would be t, and then it will like go through again to find k, right? And then it's going to be 1.
So if you pass this K to this length here, then the first invocation will have the X be in the ASCII code of uppercase T, because it is inversing the first G, which means we're getting back the ASCII code of T and the encoded version of AK and then the null character. Is that okay? So when you perform the recursion, when you call length again with this Y is really the encoded version of AK and the null character, which is the value of this application of G. So when that value of n is getting to the second invocation of length, when you decode it, then the ASCII code of A will then be stored in local variable X, and then the encoded version of K and the null terminator is going to be the Y of the second invocation of length. So then you pass that Y to length again, you call it one more time. So in that particular invocation, I will unravel the G value of K and the null character, which means X is going to be the ASCII code of K, and Y is going to be 0. But I'm still going to do the recursion here, because the 1 plus the 1 is accounting for the non-null character K, but I'm still going to call length again, even though Y is already 0. But that's okay, because when you call length with an argument of 0, then n is going to be 0, which means we fall into the else case, and the result is going to be 0, which means the length of a string encoded into a natural number of 0 is in fact 0. Yep.
So you just call g to the negative 1 until you get 0 back, and then
You get the two components back. The first component is the character, the first character of that substring, and then the second component is the encoded version of the rest of the string.
the number of times you call g to the negative 1 until you get 0 is the length of the string.
Yes. Basically, that's why we have the 1 plus before when we do the recursion.
You just count the string.
Huh?
You just count the string in the first place.
Yes. Now this can be done non-recursively too. You can just use a loop. Okay. In my mind, recursion makes more sense, but to some people, an iterative algorithm makes more sense. So if you want to use an iterative version of this algorithm, it's perfectly okay with me. Okay, there's no problem with that. Just use a while loop. Okay, so use a while loop to unravel xy until y is 0. And every time you go through the loop, add 1 to the length. That's it. So there are several ways to approach this problem. Question number 4. Yeah, we still have some time, so we're good. So question number 4 is asking, consider C is not an empty set, D is not empty. Huh? Oh, so C, D, E, and F are all non-empty. Okay, I'm defining F1 as a function where C is a domain and E is its codomain. I'm defining F2 where D is the domain and F is the codomain. So are we okay so far? Okay, we have 4 sets, non-empty. we are defining two functions, where C is the domain and and E is the codomain, D is the domain and F is the codomain. Now we define F3, which is the union of F1 and F2. In all cases, is F3 guaranteed to be a function? And then the question also adds, if so, explain why it is the case, starting with the definition of a function. If not, present an example where the cardinality of the sets that you use are all greater than or equal to 3 to show that at least in one case, okay, F3 as defined is not a function. And be sure to include the definitions of all the sets. Spell out the actual content of D, E, C, D, E, F, okay, so that I can actually look at the concrete example and go like, yep, you definitely got it. Okay, so what do you think? Is F3 guaranteed to be a function? Yep. 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 So the union is going to have one element in the domain mapped to two things in the codomain. Yep. Okay. So now it's time to come up with the counterexample. In other words, I now know that, or have a very strong suspicion that this is not true. F3 is not guaranteed to be a function. So what's left to be done is to find a counterexample. Show me an example where it meets all of these requirements, but F3 is not a function. So what am I going to do? The restrictions already says, okay, so I can do it here because I can just type out the content. So I can say, C equals D equals E equals F. Okay, that makes my job easier. 3, okay? So because I need a cardinality of at least 3, so 1, 2, 3 is fine, okay? And then I proceed to define, what F1 is going to be. So forgive me if I don't use a subscript because it's just going to take up extra time. So F1 is going to be a set. F1 is supposed to be a function to map from C to E, but since all the sets are really the same, so I can just say, okay, 1 maps to 1, 2 maps to 1, and 3 maps to 1. Is F1 a function? Going from set C to set D. Yep. The question doesn't say anything about injectiveness or surjectiveness, so you have freedom to make it not injective and not surjective. Cool. And what about F2? Well, we can define F2 to be 1 maps to 2, 2 maps to 2, and 3 maps to 2 as well. So everything maps to 2. So what is F3? But Tack, you have never talked about how to make a union out of two functions. Do not look at these as functions. F1 is a set. F2 is a set. You can make a union of two sets. Okay? So the union of two sets simply has elements from both of the sets. Okay? So in this case, they don't even intersect. So you just throw everything in, right? Okay, so now we have 1, 1. Whoops. Okay, I'm going to cheat here. Control C and paste. There you go. I don't have my favorite keyboard, so that's why this is actually twice as slow as my usual keyboard skills. I used to carry my own keyboard around, but turned out to be too much trouble. Okay. So, is that okay? F3 is the union of F1 and F2. F1 is a function. It meets all the requirements of a function. Every element in the domain is mapped to one element in the codomain. F2 meets the same requirement. The union has a problem, because now you can say, wait, 1, which is an element of the domain, is mapped to 1. It's also mapped to 2. That's not good, because in a function, each element of the domain should map to one element in the codomain. This is mapping it to two elements of the codomain. It is not a function anymore. Okay? So even though I'm only showing you these, okay, you still have to use words to kind of describe what a function is and why f3 is not a function. Now you can do it verbally. You don't have to use the for all, blah, 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 blah. You can just say that, in a function, every element in the domain should map to only one element in the codomain, and f3 is mapping one to two different elements in the codomain. Therefore, it is not a function. That would be fine. So no need to use the for all and all the symbols. But if you want to do that, that's fine too. So are we good so far with question number 4? All right. Do we have a number 5? Yes. So we have a number 5. Given that f is a function, d is the domain, e is the codomain, it is injective but not surjective, so it's given to you. State in all cases how the cardinality of f relates to the cardinality of d, as well as how the cardinality of f relates to the cardinality of e. In other words, what I'm asking is the following. Okay, f question mark, okay, cardinality of f question mark, the cardinality of d, and the cardinality of f question mark, the cardinality of e. Tell me equal to, greater than or equal to, less than or equal to, does not equal to, or we simply cannot tell. Okay? So explain your answer, and starting with the definition of injectiveness and surjectiveness. What does it mean when I say a function is injective? What does it mean when I say a function is surjective? Okay? You got a few ways to do it. You can just explain in your own words, okay, that injective means every element in the domain maps to a distinct or unique element in the codomain. Okay, that's fine. Okay, I can understand what is unique and what is distinct. Surjectiveness means everything in the codomains are mapped to. Or if you like to copy and paste, okay, using your handwriting, you can go to my definition in my notes and copy and paste it. Okay, that would be fine too. Now, if you say, I'm going to sacrifice my printout, cut literally, and scotch tape it onto my the paper, that is fine as well. Literally, cut and paste, okay, with scotch tape or, how do you call those things? Glue stick, that's it. I don't like messy glue, but glue stick is okay. Okay, because it means that you know where to find it, and you know which one is which one. Okay, that's all I want. Okay, but then you still have to answer this question. Okay, how does the cardinality of f relate to the cardinality of d? And you have to consider that it is injective but not surjective. It has to be equal to. It has nothing to do with injectiveness or surjectiveness and all that crap, because as long as f is a function, the cardinality of the function has to be the same as the cardinality of the domain. That has nothing to do with injectiveness and surjectiveness and all kinds of crazy stuff like that. But E is a little bit different. Okay? So why is E different? Now, in order for the function to be injective, it means every element in D is mapped to a distinct element in E. Right? So that means E needs to have at least as many elements as there are in D to satisfy that requirement. So at this point it's greater than or equal to. But it also says it's not surjective. In other words, not every element in the codomain is mapped to, which means, cannot be equal to anymore. It has to be greater than. Because the not surjective part is ruling out the equality possibility. So it actually has to be greater than in this case. So even though I'm only giving you the summary of the answer, I'm verbally explaining it, which means you actually have to put that part into your reasoning when you write down your answer. Okay? Now you don't have to have complete sentences. In fact, I prefer just points or partial sentences instead of complete sentences, especially sentences that start with I think. Okay, you don't have to say I think. I think that part is clearly implied. Unless somebody says, well, the student to my right thinks. Then I go like, well, there's a point there. And I'm gonna make that point to the dean. All right, so I think, there's a question number 6. So not yet. Yep. Uh-huh.
You said you said not all the things in E are mapped to,
Right.
but all the things that are mapped to are unique.
Yes.
Wouldn't that mean that E is greater than F?
Oh, right. The other way around. Okay. You caught me. I made a mistake. And it's recorded on YouTube. And I have no intention of deleting it from YouTube, so now that mistake is recorded for eternity. Huh? I don't bother. Is that okay? All right. Well, we are running out of time. I don't want to hold the other class, hostage. So there is a question number 6, but I can't really get around to explain that one in class. So what I'll do is I'm going to record it, and then I'll send you, a notification that, the explanation of that one is recorded. I'll try to do it tonight. If you don't see it tonight, send me an email and kind of nudge me and go like, hey, where's the explanation of question 6? That works for me.